Okay guys, welcome to today's class. Now in today's class we are going to be answering some of the test questions in our previous test, that is the 2018/2019 academic session. We are going to profile solutions to the test questions. Now please, while going through the video, make sure that you subscribe to this channel and turn on the notification button so that you will be the first person to be notified whenever we upload a new video. And also please make sure you invite your friends to our e-lesson channel so that they will become a partaker and a beneficiary of everything that we have to offer. Now the first question here says the ground state configuration for arsenic is, the ground state configuration of arsenic is, now we have arsenic. For us to write the electronic configuration of any atom or of any element, it's essential that we do what? Now we know the atomic number of that element. It's essential that we know the atomic number of that element. Arsenic, As, has atomic number of 33. It has atomic number of 33, and the electronic configuration, according to the Hund's rule, the Albers principle, while filling electrons, you fill into the energy level with lower energy before filling into the one with what? Higher energy. So filling this arsenic As2 into appropriate orbital, you have 1s2, 2s2, 2p6. How many have we filled now? 2 plus 2, 4 plus 6, 10. Then we have 3s2, 3p6, 4s2, 3d10. Then how many have we filled now? This is 10, 10, 30. 3d10. Then what are we going to have? We are going to have 4p3. So this is the electronic configuration of what? Arsenic. This is the normal electronic configuration. That means unabridged, not the condensed, uncondensed, if there's any word like that. Electronic configuration of arsenic. Now, how we got to this electronic configuration of arsenic? What if you look at your options and this was not given? What if you are given the condensed structure? Now, in that case, you look for the noble gas that is closest to what? Arsenic, and then from there you'll be able to write the electronic configuration. The noble gas closest to arsenic is argon. Argon what? With atomic number of 18. So what you are going to do is to write the condensed electronic configuration. You write arsenic is equal to, you put argon in bracket, then you cancel 18 from this long electronic configuration. So how are we going to cancel 18? This is 2, this one is out, this is out, 4, then we have what? 10, then we have 12, then you have what? 18. It means that this entire from here to here represent what? Argon. So what we are left with? We are left with 4s2, 3d10, and 4p3. So this is the condensed electronic configuration of what? Arsenic, and that makes option B the correct answer. Argon, 4s2, 3d10, and 4p3. But if you are given this in the question, you should what? Use this to solve and get your correct, or you should choose this as your correct answer. So that's pretty much for that question. Now let's look at the next question. The next question says the outer electronic configuration of NS2, NP4 corresponds to which of the following elements in its ground state? Now the electronic configuration is indicative of the group or the outer electronic configuration or the outer valence electrons is indicative of the group of the element. So whenever you are given NS2 and NP4, what group do you think it will belong to? Now, because you have N and N, it means that the energy levels are what? The same. It means that the outer energy levels are what? The same. And if the outer energy levels are the same, what do we do to get the outer valence electron? We add them together. This is not the valence electron, but the sum of these two. Reason be that N and N are the same. And whenever the number or the valence shell is the same, what do you do to the valence electron? You add them to get the total valence electron. So this gives us 2 plus 4 is 6. So this is 6 valence what? Electron. What group in the periodic table has 6 valence electron? They are the chalcogenes. So we are going to look at the options given to us and choose the one that corresponds. We have option A, sulfur. B is calcium. C is chromium. And D is bromine. Now, the correct answer is what? Sulfur. Sulfur is the only element there that belongs to what? Group 6 and is a chalcogen. So that's pretty much what. We have the next question. The next question says, select the term best described in series of elements: manganese, iron, cobalt, nickel, copper. Now, these elements, they are known as the transition elements. We have manganese, iron, cobalt, nickel, copper. These elements are known as the D transition metals. So the general name for representing them is the transition metals. So that is pretty much for that question. Now, which of the following has the largest atomic radius? Next question. Which of the following has the largest atomic radius? The options given to you are lithium. Then we have sodium. We have calcium, and we have magnesium. Which of the following has the largest atomic radius? Now, what is atomic radius? Of course, we know the definition of atomic radius. Now, the most important thing is not the definition, but rather the trend in the atomic radius. In the periodic table, we are made to understand that the atomic radius increases from top to bottom down a group because more shells are added, and decreases from left to right across a period. The atomic radius increases from top to bottom down a group, and thus what decreases from left to right across a period due to what? Increase in the effective nuclear charge. So that is pretty much for it. Now let's look at this atom. We have lithium, sodium, calcium, and magnesium. Let's group them into their different groups and periods. We have lithium. This is a group 1 element. Then we have sodium is also group 1. Then we have magnesium. This is group 2. And we have calcium. This is group 2. Now we are going to discern which of them has the highest atomic radius. Now from left to right, as you go from left to right, lithium has the highest, because we said as you go from left to right, the atomic radius does what? Decreases. So in this case, lithium has the highest from left to right. Now from here to here, sodium has the highest. Reason being that we are told that from left to right, it what? Decreases. So if it decreases from left to right, that means this one has the highest. As you are going, it decreases like that. So this one has the highest. Now let's consider them from top to bottom. Now from top to bottom, we are told that as you go down, the atomic radius does what? Increases. As you go down, the atomic radius does what? Increases. So between lithium and sodium, which one has the highest atomic radius? It does what? Increases from top to bottom. It means that sodium has the highest atomic radius of all these species. And that is pretty much the answer. It's very easy. The first thing is to actually classify them into their different groups and period, and then analyze like that. Now we have the next question. The next question says, which of the following elements violates Octet rule? Which of the following elements violates the Octet rule? We have PCl3, then we have CbRO4, and then we have NF3, and the last one is AsF5. Now, whenever you are given a question like this, the easiest thing to do is just look at them. Anyone that has central atom or anyone that has atoms surrounding it greater than 4 violates the Octet rule. So this one that is greater than 5 automatically violates the Octet rule, because this arsenic has 5 valence electrons, fluorine has 7, fluorine has what? 7, arsenic has 5. Fluorine is more electronegative than arsenic, and from our discussion or from what we know, that while writing or while drawing the Lewis dot structure, because the Lewis dot structure will actually give you information whether it violates the Octet rule or not. Because the reason why all atoms goes into bonding is for them to complete the Octet rule as proposed by G.N. Lewis. Are we getting it now? So in this case, what we are going to do is draw the Lewis dot structure for the both of them. And the rule for drawing the Lewis dot structure is that the least electronegative atom should be the central atom. The least electronegative atom should be the what? Should be the central atom, but on no account must hydrogen be the least electronegative atom. On no account must hydrogen be the central atom. Of course, hydrogen is not given in this case. So between arsenic and fluorine, which one is more electronegative? Of course, we know that fluorine is one of the most electronegative elements in the periodic table. So fluorine is more electronegative than arsenic. Of course, you also know that while deciding this, the one that carries more molecules here or the one that carries more atom is never the what? Central atom. So arsenic is the central atom. So we have arsenic, five electrons, fluorine 7. So we have arsenic, again. Now we have arsenic. It has 5 valence electrons, which we are going to fill here. Now, fluorine has 7 valence electrons. Each of the fluorine brings 7 electrons. But fluorine needs 1 electron each from arsenic to complete its outermost shell. So what are we going to get? We have fluorine here with 1 electron coming. Then we have the other lone pairs bonded to fluorine. Same thing is applicable here, like this, 7, 8. So we have another fluorine atom here, 1, 2, 3, 4, 5, 6, plus this 7. Another fluorine atom here, 1, 2, 3, 4, 5, 6, 7. And another fluorine atom here, 1, 2, 3, 4, 5, 6, 7. Now, if you count around the central arsenic atom, there are more than 8 valence electrons. There are more than 8 electrons. Let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you see that arsenic is having more than the required what? Octet, which is 8 electrons. Hence, arsenic violates the octet rule, or this compound violates the octet rule. So that is that for that question. Now you can draw the Lewis dot structure for the other ones. You can draw for PCl3. This one has 5 valence electrons. 1, 2, 3, 4, 5. Then we have Cl. This. Of course, we know that we have other electrons like that. If you count 1, 2, 3, 4, 5, 6, 7, 8. CBRO has this and this. BRO. One, 2, 3, 4, 5, 6, 7, 8. To base the octet. Same thing is applicable to this. 1, 2, 3. This also obeys the octet rule, but this does not obey the octet rule. So that is pretty much for that question. Okay, now make sure you subscribe now. Subscribe. It's very important you all subscribe. Now, let's look at the next question. The next question says, what alkaline earth metal is located in period 3? What alkaline earth metal is located in period 3? Now, we have different groups in the periodic table. We have the group 1 element called the alkaline metal. Alkaline metal. We have the group 2 alkaline earth metals. We have group 4, which are called the metalloids. Group 6, called the chalcogens. Group 7, halogens, and group 8, noble gases. These are the various groups in the periodic table. Now, the question says, what alkaline earth metal is located in period 3? Now, the alkaline earth metals are the group 2 elements. The alkaline earth metals are the group 2 elements. So, which of them is located in period 3 of the periodic table? Now, period 3, we have the first period starting with hydrogen here. Then we have the second period starting with lithium. Then the third period starting with what? Sodium. Now, after sodium, to this side, this is group 1. Then we have, this is group 1. Then we have group 2. The group 2 element, you have magnesium. So the group 2 element that is located in period 3 is magnesium. Because this is the first period, second period, third period. Group 2 element in period 3 is magnesium. So we have the next question, which says that which of the following is a metal? This is a bonus question. Which of the following is a metal? Now you are giving germanium, group 4, metalloid. Arsenic is not. Fluorine is not. Then we have vanadium. The metal that we have here is vanadium. Reason being that vanadium is a metal. It's a transition metal rather. The transition metals we have starting with scandium, titanium, vanadium, manganese, iron, like that, like that. All these are what? Transition metals. They are transitional between the main group element and the what? Non-metals. Is that clear? So this is a bonus question. Correct answer is vanadium. Now, we have which of the following statement is wrong? The atomic weight of carbon is about 12. That is true. Atomic weight of carbon is about 12. That is true. The most stable ion of lithium is lithium plus. Lithium with a positive ion. That is correct. Reason being that lithium is a group 1 element and the most stable ion is equal to the group or the number of electrons that ion can easily give out, and group 1 element can easily give out one electron to form a positive charge. Hence, lithium has the most stable ion as +1. Now we have C. A phosphorus atom is larger than an antimony atom. Is that true? A phosphorus atom is larger than an antimony atom. Is that true? That is false. Phosphorus and antimony are the same group in the periodic table. We have phosphorus, then we have antimony. They are in the same group in the periodic table. But phosphorus is at the upper part of the group and antimony is under. And we are meant to understand how something happens when you go from up to down in the periodic table. The atomic radius increases. This is due to increase or addition of more shares. So when we go from potassium to arsenic, the atomic radius does increases. And because the atomic radius increases, the atomic radius of arsenic is larger than that of potassium.
Oh my God,
so
why am I using potassium and
says,
arsenic?
the
It's supposed to
radius
be
of sodium
phosphorus
atom is larger than the radius of
antimony.
sodium
Please take
cation.
correction.
Is that true? Radius of
Phosphorus
sodium
and
atom is
antimony,
larger than
not
the radius of
potassium
sodium
and arsenic.
ion. Now,
Take correction.
you should know this.
So that you don't say I don't know.
For positive ions, the positive ions are smaller than the parent atom. Positive ions are smaller than the parent atom. Why the negative ions are larger than the parent atom? Positive ions are smaller than the parent atom and negative ions are larger than the parent atom. Reason being that when you are giving out electron, you are removing a particular shell. Are you getting it? So if you had, let's say, something like this initially, if you had a shell like this initially, and you are giving out this shell out, what will be left? You'll be left with just two shells. So that makes positive ions to be lesser, because this is not the ion. You've removed an electron. The electron is going with a shell. That makes the positive ions to be smaller than their parent. This is the parent atom. It has how many shells? 1, 2, 3. But the ion is having how many shells? Is having just 1 or 2 shells, because one particular shell left when you gave out the electron. So they are smaller than their parent atom. And that means the radius of sodium atom is larger than the radius of the sodium cation is true. So the correct answer is this. This is false. Phosphorus atom can never be lesser than arsenic, or can never be greater than the arsenic atom. The phosphorus atom can never be larger than arsenic atom. Is that clear? That's it. So that's pretty much for that question. Now we have a question that says, which of the following molecules are polar? Which of the following molecules are polar? I'm going to spend some time explaining this. Which of the following molecules are polar? which of the following molecules are polar? You have, let's draw the molecules. You have pH3, OF2, HF, SO3. Now, these are the molecules that are given to you. Which of them is polar? Now, for a molecule to be polar, it must have a dipole moment. For a molecule to be polar, it must have a dipole moment. That means it must have a site of what? A positive charge and a what? A negative charge. Now, this is brought about by the electronegativity, or by the what? Electronegativity of the atom. This is brought about by the what? Electronegativity of the atom. Whenever two atoms with large electronegative difference are placed together, there is always a what? A dipole moment that is formed. And when the dipole moment is formed, such a molecule is what? Polar. But that is not the only condition that must be satisfied for a molecule to be polar. There are other conditions. Now, the second condition is that the molecule must not be symmetrical. The molecule must not be symmetrical. If the molecule is symmetrical, the positive charge and the negative charge, or the site of the positive charge and the site of the negative charge, cancels out, and therefore the molecule is not polar. But if the symmetry, if it is not symmetrical, then the molecule is said to be what? Polar. Now, how do you know if a molecule is symmetrical or not? Now, the easiest way to know if a molecule is symmetrical or not is to, one, the molecule must not have a lone pair of electrons. It must not have a what? Lone pair of electrons. Secondly, the molecule must have all atoms the same. If the molecules have all atoms the same, then it is what? Symmetrical. Or let's say all the atoms surrounding the central atom must be the same. All atoms surrounding the central atom must be what? The same. If all the atoms surrounding the central atom are the same, then the molecules are what? Is said to be polar. Now, let's consider pH3. Drawing the Lewis dot structure for pH3, from there we'll be able to predict. Now, we have phosphorus. Between them, of course, we know that hydrogen can never be the central atom. Phosphorus has 5 valence electrons, of which 2 become what? Lone pair. Each and every one of us can draw Lewis structure. So we have phosphorus, 2 lone pair of electrons, hydrogen, hydrogen, hydrogen. Now, we said one of the conditions for a molecule to be symmetrical is, or it must not have a lone pair of electrons. Now, for this to be symmetrical, or for this to have a lone pair of electrons, it means that it is not symmetrical. And when it is not symmetrical, the tendency of it being polar is high. So let us also look. We have fluorine and hydrogen. There is large electronegativity difference, which is represented with this line like this. This is the dipole moment. This is the dipole moment coming from hydrogen to the more electronegative atom. Are you getting it now? Now, if you look at this atom very well, this is phosphorus. It has a lone pair of electrons, it has dipole moment. That means it has a site of positive charge and negative charge. So this molecule is what? Is polar. It's polar. As we take other examples, you understand well. Now look at fluorine, OF2, oxygen difluoride. Now OF2 has oxygen as the central atom. Oxygen has how many valence electrons? It has 6. So we have fluorine also bringing 7 electrons. Sorry. So the molecule, or the molecular geometry for this compound is something like this, with 2 valence electrons. Now this makes it to what? To not be symmetrical. It's not symmetrical. Why? Because it has a lone pair of electrons. Now, since it's not symmetrical, now look at the oxygen fluorine bond. There's a dipole moment. This is partially negative. and this is what? Partially positive. Sorry, this is partially negative, and this is partially positive with two lone pair of electrons. Because it has a partially negative end and a partially positive end, it is what? Polar. And it's not what? Symmetrical. It has a dipole moment. So if it has a dipole moment and it is not symmetrical, such a molecule is polar. So this one is polar, this one is polar. Let's look for HF. Now the Lewis structure for HF is very easy. Of course, we know we have our other lone pair of electrons. First of all, it has a lone pair of electrons. It's not symmetrical. Secondly, the two atoms, they have a site of what? Positive end and what? Negative end and what? Positive end. So it has a dipole moment, and the two atoms are what? Different atoms. Hence, this compound is what? Non-polar. So each of them are what? Non-polar. Now let's look at SO3. Now SO3 has S as the central atom. Then we have oxygen. Oxygen is sulfur has two electrons. Let's say it has this. Now oxygen needs how many electrons to complete its atomic shell? It needs 2 electrons each to complete its atomic shell. Let's leave the lone pair. Of course, we know that they are supposed to be there. It needs another 2 electrons. Remember to put your lone pairs. It needs another 2 electrons. Now, if you look at this compound very well, what can you see? The compound has what? It has. Let me clean one part. If you look at this compound very well, it has, you have sulfur in the middle, oxygen. Now we are not going to draw the lesson now, so of course you know the way it is like this is balance the octet rule. It must be like this. X, O. This is a discussion for another day. Then this one will not be like this. This is a discussion for another day. Now, while looking at molecular geometry, a double bond is considered as one electron group or as one group around the central atom. Now, if you look at this very well, this has partially negative, partially positive, partially positive, partially negative, partially positive, and partially negative. But if you see, so first of all, it has the dipole moment. That is one. Now, since it has a dipole moment, there's tendency for it to be polar, but is it polar? No, because we have 3 atoms that are arranged. They have a what? A symmetry. They have a what? Symmetry. They are symmetrical. When we say something is symmetrical, it means that they are the same. Like this oxygen is the same with this oxygen, is the same with this oxygen. Unlike hydrogen and fluorine that are different, OF2, although they are symmetrical, but because it has a lone pair of electrons, that distinguishes it, or that makes it to be not be what? Symmetrical again. Then pH3, although they have 3 the same electron or 3 the same atom surrounding the central atom, but it has a lone pair. We say the condition for symmetry is that 1, it must not have a lone pair. Secondly, it must have the same atom what are surrounding it. So if you look at this one that we consider, it has the same atom surrounding it, but it has a lone pair. And because it has a lone pair, what happened to it? It is not what? Symmetrical. Although it has a dipole moment, but because it is not symmetrical, it is what? Polar. Same thing applicable to this. They have the same atom of fluorine surrounding them, but because it has a lone pair, that makes it not to be what? Symmetrical. Is that clear? And that is polar. HF, same thing is applicable. Different atom is what? Polar. But for this one, you have different atom, although it has a dipole moment, but you have the same atom, and it does not have a lone pair of what? Electron around the central atom, and therefore this one is what? Symmetrical. So since it's symmetrical, we say this molecule is what? Non-polar. And the question says, which of the following molecules are polar? So the correct answer is all except SO3. All except SO3. SO3 is not symmetrical. Now, it's not polar. Condition for polarity: one, it must have a dipole moment. That means it must have positive and negative what? N, and that can be got from the electronegativity difference. Secondly, it must not be what? Or it must be symmetrical. Condition for polarity: it must not be symmetrical, rather. Condition for polarity: it must not be symmetrical. But if it is symmetrical, then it is non-polar. And how do you know whether a molecule or an atom is symmetrical or not? One, it must not have a lone pair of electron. If it has a lone pair of electron, then it is not. Now we have another question that says, in the ground state configuration of a cobalt atom, there are dash unpaired electrons and the atom is said to be. Now, whenever an atom has unpaired electron, we said that that atom is paramagnetic. Now, if it has no unpaired electron, that atom is what? Diamagnetic. If it has unpaired electron, it is paramagnetic. If it does not have, it is what? Diamagnetic. Now let's look at the electronic configuration of what? Of cobalt. Cobalt has atomic number of 27. Now if cobalt has atomic number of 27, what's the electronic configuration? This cobalt, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d. Let's count 10, 10, 12, 18, 20. Then we have what? 27. Now, from magnetic quantum number, let's just draw for the outer valence electron, because all of these ones are filled. Our main focus should be here. So we have 3d7. Now, the d orbital can take a maximum of how many electrons? 10 electrons, which are split into how many orbitals? 5 orbitals. So we have 1, 2, 3, 1, 2, 3, 4, 5. You can take 10 electrons. So this is 3d7. Let's fill the 3d7. According to the Hond's rule, while filling electrons into appropriate orbital, what happens? You fill singly before what? Pairing. So filling singly before pairing, we have 1 electron into it. 1, 2, 3, 4, 5. We have 6, 7. So this is the electronic configuration of 3d7. How many unpaired electrons do we have? We have 1, 2, 3. So it has 3 unpaired electrons. And we say when an atom has unpaired electrons, that atom is said to be what? Paramagnetic. So the correct answer is it has 3 electrons and it is paramagnetic, which is option A. So watch out for part 2 of this series. Please subscribe to this channel and also turn on the notification button. And also make sure that you are studying your books. Make sure that you are studying your books. A man once said that the heights attained by great men were not of a sudden flight, but while others were sleeping, they were doing what? Toiling what? Upward in the night. The best thing you can do to yourself is self-investment. You add value to yourself. And the only way you can add value to yourself is what? To gain more knowledge. To gain what? Self-awareness. And we get it in all aspects of life, not just in chemistry only. But since you have chosen to be in school, you should make sure that you give your best in school. So that will be all for now. Subscribe, invite your friends, and turn on the notification button. I love you all. Bye-bye.